All right, we are ready to begin. So welcome to week 2, class 2. Today we're going to start on chapter 2, which is a key chapter in the development of our skills. Specifically, we are now going to introduce 3 ideas over the next couple of weeks that are going to be used over and over and over again for the continuation of the semester, specifically measures of central tendency, measures of variability, and z-scores. So we're going to take those piece by piece by piece. We're going to start today with measures of central tendency, and specifically the mean you're going to see is the most important one for us as psychologists. But just kind of remind you of what we're trying to do here. This is all part of building your skills, building your abilities, and practicing this over and over and over again. So I have no doubt whatsoever that you have all calculated the mean before at some point in your academic careers. However, we need to make sure that at this point we practice it enough so that it is rock solid, so we know exactly what it is, so that when it's embedded into something that's super cool but super complex, something that has a lot of moving parts to it, we don't have to think about it at all. It's just automatic. It's just there. And that, again, comes through practice. So let's set up today's topics with a bit of a hypothetical situation here. So let's say that you graduate from IUSB. It's coming back. Let's say that you graduate from IUSB and you become an educational psychologist. And you do work in the factors that really allow students to reach their learning goals. And let's say that your work captures the attention of the governor of Indiana, and he's thinking to himself, I got money in the budget right now, and one of the things that I want to invest in our state is I want to invest in higher education. I want to make sure that our workforce is highly educated, that people are getting the careers that they would like to get, that everybody has an opportunity for higher education. So he wants to know how much money to put aside. And one of the things that will allow him to make that decision is to know how much does the typical student receive, how much funding or resources, monetary resources, does the typical student have. So whether that comes from scholarships, whether that comes from a part-time job, whether that comes from parents, whether that comes from whatever source it might be, he wants to know how much is the typical student starting with so that he can set aside enough of the budget to make sure that enough funding is available. So for that, he would call you up. Let's say that you did studies where you would interview students and you would simply go to universities and say, how much funding are you receiving? How much money do you get from work, from parents? Let's say that you have done this analysis. If you have done this analysis, you might have interviewed 10,000 individuals. You will have 10,000 raw scores. You will have 10,000 different amounts of funding. And if you reported those 10,000 to the governor of Indiana, it would make no sense to him whatsoever. Our minds are just not made to handle 10,000 scores. What does make sense is one score, one number, one score that you can give this individual that will give them an idea of what the typical student is dealing with, that'll give them an idea of what the average student has access to, that will give them a representative number so that they can take that one number and have a pretty good idea of what those 10,000 numbers are like. You can take those 10,000 numbers and summarize them meaningfully into one number, and that's what we're going to be looking at today when we look at central tendency. So the plan for today, we're going to talk a little bit more about that representative single score. We're going to introduce 3 measures of a representative single score, the mean, the median, and the mode. And those are listed in order of how often they are used in psychology and in psychological research. We're going to see how to calculate the mean, the median, and the mode, characteristics of the mean, the median, and the mode. And today is going to be laying the foundation for what these measures are so you can kind of see the internal workings of it. Next class, we're going to go into how to actually calculate all of these using Excel and in Excel formulas. All right, so that idea of a representative single score, that's what we're measuring with central tendency. We want to have a single score that defines the center of a distribution. So we introduced frequency distributions last time. This is a great example of what I mean by having practiced things enough so that you're becoming very, very familiar with them. So when I say single score that defines the center of a distribution, if you have distribution down and you know, oh, that's a frequency distribution. And when I talk about distribution, you can kind of see the histogram in your mind. And you understand that that histogram, that bar graph, has a center to it somewhere. That's going to go a long way to understand this next concept of a central tendency. If at this point you're still sitting there going, well, wait a second, what was the distribution again? It was an ordering of the frequency of the numbers. If you're still at that point, the more you build, the harder it's going to get to hold everything in your mind. So this is just a PSA, public service announcement, to make sure that you are getting very familiar with these. If you're not quite there yet, keep practicing, it will come. All right, so it's a single score that represents the center of the distribution. A single score that's the most typical score. It's a representative score for the entire group of scores. And as we just mentioned, we have three that we use in psychology the most often. And the fact that we have three should be a clue that not everybody always agrees on how to get that single representative score. So we're going to talk about the pros and cons of these, but just be aware that it's not straightforward to find out what is that single representative score, and that's why we have those three different ways. So let's take a look at an example of a single representative score. Let's say that today, this morning, aliens come from outer space. They land on Earth, and an alien pops out, and instead of saying, take me to your leader, this alien says, look, I want to know about humanity. I want to know what humans are like. I see that you have a bunch of people on this earth. I see that you're all very, very different, but we don't have time to talk to everybody. Take us to your most typical human. Take us to that one human that once we meet them, we will know what you are like. We will know what the population of humans is like. We want to talk to one individual. The question then you would have is, which individual? Who do you pick? So some people you would not pick, right? So you would not pick Neil deGrasse Tyson, right? Because that would just overestimate how intelligent, scientifically knowledgeable the human race is. And you would not want to pick Simone Biles, right? Too agile, too powerful, too gymnastic, right? She is not a typical human being. You would not want to pick Hafthor Bjornsson, too big, too strong. Once again, would give them a massive overestimation of what humans are like. Who you would want to pick is you would want to pick somebody like Luke Wilson's character from Idiocracy. So if you've never seen this film, here is a description of his character from Idiocracy. So he was chosen for a cryogenic freezing experiment, and this is the reason that he was chosen.
Okay.
One second, let me make sure it's all cranked. Yep.
Here is not one of our best men. Mr. Bowers was chosen primarily for how remarkably average he is. Extremely average in every category. Remarkable, truly. The most average person in our entire armed forces. Additionally, he has no family. He's unmarried.
All right, so that's exactly what you would want. You would want somebody who is the most average across the board. Average intelligence, right? You want somebody who has average blood pressure. You want somebody who has average heart rate, who has average overall health. You want somebody who is typical, doesn't overestimate, doesn't underestimate. That's the kind of person that you want. That is representative of the entire group. So that's going to be what we're going to work on today in a series of numbers. So instead of dealing with humans, what if you were dealing with a series of numbers? How do you find that one number that's going to represent the entire group, represent it well, so that somebody will get an immediate understanding of your distribution simply from that one number? All right, so to deal with that, we're going to deal with the following hypothetical frequency distribution. And once again, hopefully, when you see this graph over here, you are starting to be able to read it automatically and starting to be able to say, all right, well, this axis here, this is frequency. So the higher the point on the axis, the more frequent that particular score is. This axis over here, these are the possible scores. So this possible score over here has a high frequency. This possible score over here has a low frequency. This possible score over here has a low frequency. Hopefully you're getting to that point where it's starting to become a little bit more automatic. If not, make sure that you continue to do the practice, do the reviews, and do the extra practice where available. So this is completely hypothetical. This is completely made up, but we're going to use it for our purposes. Let's say that this is the frequency distribution of funding that students typically have access to here in Indiana when they go to university. So breaking this frequency distribution down, we can see that there are very, very few students that have access to absolutely no funding whatsoever. So no part-time job, no scholarship, no financial aid, no parents to help them out, no friends that they can borrow money from, no time to stand on the corner and panhandle, like nothing, right? There's almost nobody that has absolutely nothing in terms of funding. And then as the funding increases, then the number of students that have access to that amount increases as well. So there's more students that have access to approximately $10,000. We'll just say this is $10,000 a year. And then right about here at 15, we have this really huge hump where many students have access to that amount of funding. And then as the funding increases, the frequency with which students have that amount of funding decreases. So students here would be ones with maybe part-time jobs. Students here would be ones with full-time jobs or maybe full ride scholarships. Students over here would be ones with well-paying full-time jobs. And then, as you get higher and higher, these would be students that are independently wealthy. These would be the students that are, the children of millionaires. It gets fewer and fewer as you go along. So let's say that that's the data that you're working with. That's your 10,000 scores that you collected as an educational psychologist. What one number is best going to describe those 10,000 scores? One of these, these are the three measures of central tendency. One of those is going to be your best number. So let's take a look at each of those in turn to see what they're all about, what they actually are. So the mean is the first one that we're going to introduce. And the mean is what you've been computing anytime you've computed what people outside of statistics will call the average. So if you've ever wondered, what's my average grade? If you've ever wondered, what's the average height? If you've ever taken a series of scores, added them all together, and then divided by the number of scores you have, you've calculated the mean. So this is computed by taking, again, all of your scores, summing your scores, so you can see how important summation of scores is. It's summing all of your scores, and then dividing by the number of scores that you have. And what the mean is, in this case, it's that score right there, so just under 20,000 in this example. What that mean can be thought of or conceptualized as is that's the balance point for all of your scores. So if you were to take this frequency distribution and you were to carve it out of wood, right? If you took a block of wood and you cut it so that it looks like this frequency distribution, then that point right there where the mean is, that's where that block of wood would balance. That's where you could balance it on your finger. It's the balance point for all the scores. And what that means is that the mean takes into account the side that a score is on. It takes into account the frequencies that a particular score has, but it also takes into account how far away the score is. So just like if you had two weights in your hand, if you were carrying groceries home and you had two bags that weighed the same and you were holding them like this, if you put one bag further away from your body, you're going to start tipping and you would need to move where you are in order to rebalance them. The same thing with the mean. The mean not only takes into account how heavy the bags are, how heavy the scores are, but it also takes into account how far the scores are away from the center of the distribution, and it has to adjust accordingly. All right, so that's the mean. The symbol for a mean, if you're dealing with a sample of scores, if you're dealing with a subset of the population, the mean is symbolized with a capital M. If you're dealing with the population entirely, you're dealing with all of the scores, the mean would be with the symbol mu. So, for example, if I was investigating Indiana University students, and I collected data from every single university student in the state of Indiana, I would be dealing with the population of students, and the mean that I calculated from their scores would be this. I would use this symbol mu. If, on the other hand, I was dealing with a sample, a subset of Indiana University students, for example, if I asked everyone in here about the amount of funding that you received, then that would be a sample. And if I calculated a mean based on this subset of data, that would be the symbol over here. So I'm making that point right now for two reasons. Number one, your book glosses over this up until the point when it becomes really important. And that's one of the things that I dislike about this textbook, is that it kind of mixes samples and populations. It kind of plays fast and loose with it at the beginning, and then tries to correct that idea in about chapter 5 or 6, I believe chapter 6. So rather than do that, I'm just going to point that out right off the bat. There is a difference between how you treat a population and how you treat a sample. So we'll just get that concept in our head. Samples are dealt with in one way, populations are dealt with in another way, and that is shown by the fact that samples have one symbol and populations have another. That's your sort of foreshadowing that this is going to be an important distinction later on. The other thing that I want to point out is that the mean is used so often that it gets its own symbol. Anytime you see something in statistics that has its own symbol, that means that it is widely used and very important. So it is important enough that they used it over and over and over again, that they wanted to stop typing in mean all this time. So they said, you know what? Capital M for a sample, Greek letter mu for a population. And third thing, I'll add another one. When you see this capital M, definitely do not read it M. Read this as sample mean. When you see this Greek letter mu, do not read it as mu or as weird looking U. Read this as population mean. Train your brain, get into that habit of making your brain recognize that, so that when you get to the exam and I ask you to calculate M, you're not going to think to yourself, what's an M? You're going to say to yourself, let's calculate that sample mean. All right, so that's the mean. Next one up is the median. So the median is the next most used measure of central tendency in psychology. So the mean is by far the most used. And if you were to take a look at psychology experiments, psychology reports, and take a look at the measure of central tendency that they use, I would estimate about 90% of them use the mean. It's massively important. It's the one that's used most often. In second place, we have the median. I would say the median is used about 8% of the time when you're calculating a central tendency. And what the median is, it is simpler than the mean. It's a simpler concept. It's simply the score that divides your distribution in half. It's the score right there that divides your distribution so that above this score, you have 50% of your distribution, and below this score, you have 50% of your distribution. So if you have 10,000 scores, if you have 10,000 points of data, the median is going to be the number where 5,000 scores are below that number and 5,000 scores are above that number. And that's all that the median cares for. It doesn't care about balancing the weight of these numbers like the mean does. All that it cares about is that if I look to the right, I have the same number of scores as if I look to the left. That's all the mean does. It just cuts them down in two. All right, I mentioned that it's not as important as the mean. The median is not as important as the mean or as widely used. And that is reflected in its term. It's called the median. So it doesn't get a symbol. And what's more is they don't make a distinction between a median for a sample and a median for a population. So that immediately tells you how important the mean is. Not only does it get a symbol, it gets two symbols. One for a sample, one for a population. The median is just the median. All right, and then finally, the last one that is widely used in psychology, but definitely in third place, I would say this is the remaining 2 to 3% of measures of central tendency, is the mode. And the mode is simply, you can think of it as, being in the mode, being very fashionable. This is simply the score of the category that has the highest frequency. So it is the most popular score. It is the most common score. And this is actually the one that's easiest to visually calculate when you take a look at a frequency distribution, because all you need to do is find the score that has the highest peak. So you'll notice here in this super high peak, the mode is the score right at the tip top. The mode is that score right there. So it's about $15,000. So that is the most common score in this particular distribution. So for a sample, once again, not as important, not as widely used. So for a sample, the mode is referred to as the mode. And for a population, the mode is referred to as the mode. All right, so that's the basic ideas behind these measures of central tendency. Any questions so far? All right, so how do we calculate these? So next class, we're going to take a look at how to do this in Excel. But right now, I want to give you a peek behind the curtain so that you know what the formulas are actually doing, you know, the kind of nuts and bolts behind it, and that'll really help you sort of understand what it is that these measures of central tendency are taking into account. So when you calculate the mean, once again, you've all done this. This is just calculating the average. You compute the mean by summing all of your numbers, summing all of your scores, and then you just divide by the number of scores. And that is the formula for the mean. Now, this isn't going to be an issue yet. It's going to come up when we do variance, but again, I just want to plant that seed in your minds. Samples and populations are treated differently. At this point, this is a special exception where they're treated the same. You calculate the sample for a mean and the sample for a population exactly the same. So for a sample, there is your formula for the mean. So once again, get in the habit of reading this. Sample mean equals the sum of the scores divided by, and small n is the number of scores in your sample. So the mean equals the sum of the scores divided by the number of scores in your sample. And then for a population, the population mean equals the sum of the scores divided by the number of scores in your population. So get into that habit. M equals sigma x divided by n is meaningless. Sample mean equals sum of scores divided by the number of scores is meaningful. Train your brain, make sure that you're putting in that intentional practice. All right, so that's how you calculate the mean. When you're calculating the median, the median is the score that divides your distribution in half. All you want to make sure is that 50% of your scores are above the median, 50% are below the median. So if you have a sample, what you would do is you would take the scores in your sample, and if it's an odd number of scores, you rearrange the scores so that they're in order. You put them in order from smallest to greatest. And then what you do is you simply find the size of your sample plus 1 divided by 2. And that is just a score. So you find the score in that position. And that's just a fancy mathematical way of saying the middle score. So for the median, if your scores are odd, your median will be a score in your distribution. It'll be the middle score in your distribution. So this is, we have 1, 2, 3, 4, 5 scores. 5 plus 1 is 6. 6 divided by 2 is 3. So score 1, 2, 3, that 5 right there, that's your median score. And we know it's the median. We know we've done this correctly because if you look below the median, we have 1, 2 scores. If you look above the median, if you can, we have 1, 2 scores. We have the same number of scores above, same number of scores below. We have our median. For population, we can't show this because population sizes are huge. But if the size of your population is odd, it's the same procedure. You order the scores and you find that middle score. And it'll actually exist if it'll exist in your distribution if your number of scores are odd. But again, you just find that middle score. So above that score, you have 10,000 scores. Below the score, you have 10,000 scores. You have the same number of scores above and below. There is a slight wrinkle, slight complication if your sample size is even. In that case, we got to do just a little bit more, just one more step. So if your sample size is even, so let's say we only have 4 scores, we still order the scores. We still put them in the correct order. But this time, we have to take the average, we have to calculate the mean of the size of your sample divided by 2 and the size of your sample plus 2 divided by 2 scores. So that's just a fancy way of saying the score to the left of the middle and the score to the right of the middle. So we got 1, 2, 3, 4 scores. 4 divided by 2 is 1, 2. That's right there. We got 1, 2, 3, 4 scores. 4 plus 2 is 6, divided by 2 is 1, 2, 3. That's the score right there. And we take that 4 and the 5 and we calculate the average by adding those up and dividing by 2. And we end up with a median of 4.5. And once again, we know that this is done correctly, that we've calculated the correct median, because below 4.5, we have 1, 2 scores. Above 4.5, we got 1, 2 scores. That's what the median is. All right, so that's for a sample when it's even. Same thing for a population. You order the scores, and once again, you take whatever score is to the right of the middle, you take whatever score is to the left of the middle, take the average of those two. That's your median if your population size is even. All right, calculating the mode. Again, the mode, score or category that has the highest frequency, the most popular one, the most common one, simply the one that occurs the most often. And for a sample, you just take a look at your frequency distribution and you find the score that has the highest frequency. So in a histogram, you just find the score that's associated with the peak of the histogram. In a frequency table, you just scan down your frequency column, find the largest number, and whatever score is associated with that highest frequency, that's your mode. And it's the same thing for population as well. It's just the peak of your distribution, just in your frequency table, the score associated with the highest frequency score. All right, so those are the 3 ways of calculating the mean, median, and mode. Any questions on that? All right. So what we have to do now, we have 3 different measures of central tendency. We have 3 different ways of calculating them. And the reason that these 3 exist is because they give oftentimes 3 different answers. And they are best used in some situations, and they are best avoided in other situations. So as a psychologist, one of your challenges when you're dealing with questions such as the governor of Indiana asking you, how much does the typical student have? One of the things you have to think about is which one of these measures of central tendency should I report? Which one will actually give me a typical score that will make sense to this individual and be an honest representation of the actual situation? So you often hear that you can lie with statistics. This is one of the places where you can achieve that if you use a measure of central tendency that is the incorrect one, that's inappropriate in a particular situation. So let's take a look at how that might occur. And to do that, we're going to add in a little wrinkle into our frequency distribution. So let's consider the following situation. You've collected all this data. You have these 10,000 scores, and you have this frequency distribution. And right before you were going to go report this to the governor, the new graduating class got accepted into university. And you say to yourself, all right, we got this new graduating class. I want to include this new graduating class. I want to include these new students into my numbers. And let's say that unknown to you, these new students, they were visited during their high school years by Elon Musk. And Elon Musk visited the high school in Indiana and talked to the kids, got to know about them, got to know what they were hoping for. And let's say that he was just so charmed and so pleased with these students that he decided, you know what, when they graduate, everybody in St. Joseph County, every graduate in St. Joseph County, when they graduate, they're going to get $60,000 a year scholarship. I'm going to pay for them to go to school. I was so impressed with these individuals here. Yeah, it'd be nice, wouldn't it? I was so impressed with these individuals here that when they graduate, everybody that graduates that year, I'm going to pay for their college career. They get $60,000 a year to go to college. So this is the year. So these students graduate, they get accepted to Indiana University, and they get put into your distribution. The question is what are these hyper-funded students going to do to your distribution? How are they going to affect your measures of central tendency? So let's take a look at what's going to happen. So here we have, once again, our old distribution, our previous distribution, the non-Elon Musk hyper-funded students distribution. And we calculated the mean, and the mean is right here, right at about $18,000. And let's say that if you reported this to the governor of Indiana, the governor of Indiana would say, oh, $18,000 is not enough. I don't want my student, I don't want students in the university to pay tuition and then live below the poverty line, for their career and have to take a job and have to work extra hours. $18,000 is not enough. I'm going to set aside money in my budget so that they don't have to. They don't only have $18,000. I'm going to set aside money in my budget so that I can increase that funding. That would be the decision for the mean as calculated with the old student funding data. But what happens? We actually got to extend that line when we get Elon Musk's hyper-funded students. So remember, this is just one little county in Indiana. This is just St. Joseph County, the graduating class. So there's not a lot of them. So this is them all the way over here, all the way over at $60,000. What is this going to do to the mean? Well, this was the balance point for the mean. This is where the distribution was balanced. And all of a sudden, this small group of students got added, but it got added way over there. And that's as if you were balancing weights, and all of a sudden somebody added a weight, small weight, not a huge weight, but added it way over there. So now what's going to happen is you're going to have to move to rebalance the weights. It's a small weight, small number of students, but it's really far off to the side. And that rebalancing that the mean is going to have to do is going to take your mean from where it previously used to be, and it's going to shift it over here. And now this small group of atypical hyperfunded students, these outliers is what they're called in statistics because they lie outside of the typical range of funding in this case. These outliers have changed your mean from under 18 to just under 30,000, so about $27,000. So now if you were to report the mean to the governor of Indiana, the governor would say, oh, I didn't know that's what the typical student received. I didn't know that was the amount of funding that a typical student has. That's enough. That's way more than enough to go to school and feed yourself and live above the poverty. That's more than they need. I guess I don't need to put money into the budget for this. I'll spend it on something else. So notice that in this case, the mean would be a very poor measure of central tendency. It would be a very poor representative score because by far the most students are under the mean. And the only reason that the mean is over here is because of this small number of students that got hyperfunded. So even though you calculate the mean correctly, this would be an inappropriate time to use it because the mean is sensitive to outliers. It's not robust against outliers. That's the phrase that's used. And in this case, it would be inappropriate because these outliers have changed the mean into a non-representative score. All right, so what else can we do? Well, we can take a look at the mode. So the mode here is being represented by the god Janus, who's the god of time. So we got Janus looking back and Janus looking forward. And all we want is for the median to see the same number of scores over here as it does over here. So this was the median calculated before Elon Musk's hyperfunded students. So once again, this is lower than the mean. This is around 15,000. Once again, you present this number to the governor. The governor would say, that's not enough funding, so I'm going to set aside money in the budget, make sure that my Indiana University students have adequate funding. That was with the previous data. What happens when Elon Musk's hyperfunded students end up with $60,000 a year? Well, in this case, we have a small number of students that are being hyperfunded. And because the median only cares about numbers, it's not going to have to move that far to get to the new median. So the median is going to change, but only by a little bit, because the median is robust against outliers. So the fact that there's only a few students here, the fact that it's only students in St. Joseph County, which is not, all of Indiana, it's just a few students here, that means that the median will have to move, right? Because we got more students on this side now, it's going to have to move a little bit, but definitely not as much. So in this case, the median would be a more appropriate measure of central tendency than the mean would be. It would give you a more representative score. And in this case, notice that those small group of hyperfunded students will not change the decision. Funding is still needed, set aside funding in the budget. All right, and then the last one is the mode, here represented by Tim Gunn and Heidi Klum from Project Runway, because they are fashionable like the mode. And once again, the mode, just the most popular score, just the most typical amount of funding. And in this case, right about there, 15 grand. That number, once again, give it to the governor. Governor would say, that's not enough. We're going to set aside money in the budget to fund it. What's going to happen with Elon Musk's hyperfunded students? Well, in this case, nothing. So when you recalculate the mode, it would end up exactly in the same location because the most common score has not changed. It's still the most common score. So the mode is incredibly robust against outliers. It does not move unless you get a new most popular peak. So the mode is incredibly robust to outliers. The median, also robust against outliers. The mean, highly sensitive against outliers. Any questions so far? All right. So let's go back to Elon Musk here. And let's say that his initial idea was to fund St. Joseph County students for $60,000 a year. Let's say that's what he initially thought. And then some of his advisors came by and they said, look, $60,000 is way too much for way more than a student would need in order to go through university. And if you really want students to be able to go through university, how about instead of funding a small number of students with $60,000, how about funding a large number of students with less money, right? What about spreading the wealth so that everybody can go to university? And let's say that he decides that and he says, all right, when this high school graduates, when their graduates get into university, what I'm going to do is I'm going to give all Indiana high school graduates that year, I'm going to give them all $40,000 a year. So instead of a small group getting 60 grand, now everybody who's graduating that year is going to get $40,000. What's that going to do to our measures of central tendency? So once again, we go back to our frequency distribution. Once again, we have our original mean right there, so just under 20 grand. Once again, we have the governor deciding, yes, I got to set aside money for funding. That's not enough. And this time, we extend the graph, and now we have a bunch of students getting funded. So not just St. Joseph County, but now we have all of Indiana, all the new all the new high school graduates, all the freshmen coming in that year, we have that many students. So what is that going to do to the mean? Well, once again, these hyperfunded students is going to move the mean. So once again, it used to be balanced right at that point, but we've added another weight. And this time we've added a rather heavy weight, right? This is a large amount of students, but it's not quite as far as the previous one, but you still have to rebalance yourself if you're the mean, and this time you'll end up right about there. And once again, this is around $25,000. This would be a decision where the governor might say, that's enough, that's more than enough, that's fine. So I'll spend the money in the budget on something else. And once again, notice that this is a horrible measure of central tendency, because by far the greatest number of students is making much less than that measure of the mean. So once again, these outliers here have moved the mean to a point where it is not a representative score. Incidentally, at this point, you might be wondering, well, why do we even use the mean if the mean is so sensitive to outliers? The reason the mean is used the most often in psychology is because it takes into account the most information. So it takes into account the number of scores on each side, it takes into account the distance of the scores on each side in order to come to its decision. So in typical circumstances, the mean would be the one that gives you the best measure because it uses the most information to arrive at its decision. However, frequency distributions can oftentimes reveal outliers. This is one of the reasons why they're so important. You should always, always, always look at your data. Always graph your data, get a visual of what it looks like. And if you see something like this, just know that those are outliers. Your mean is going to be very sensitive to those outliers. So now it's time to look for something different. So just be aware of that. Usually the mean, great one to use, not always. So you can't just blindly say, I'm just going to use the mean because it's the greatest. You have to say, what does my data look like? Does it have outliers? Is this the right time to use the mean, or is another measure more appropriate? All right, so back to the three measures. The median in this case, remember before it didn't get moved very much with Elon Musk's hyperfunded students, but now we got a bunch coming in. We got way more students coming in this time. We have all the graduates in Indiana. And now the median is going to have to move to accommodate for this large increase in the number of students. And it's going to have to move more than it did before. And actually should have moved more than that. I didn't move this enough, but it's going to have to move more than it did before because now we have more students on the other side of that original median. And then once again, the mode, most frequent, most popular amount of funding, most frequent score. You get Elon Musk's hyperfunded students, and this time they, once again, would not do anything to the mode. So you might be thinking, well, we should always use the mode, but again, we don't in psychology because the mode uses the least amount of information. It doesn't count about the number of scores on each side. It doesn't care about the size of the scores on each side. All it cares about is which one is the most frequent. And the mode is very dangerous if you're dealing with a small number of data points, because if the mode is all the way over here, and we added just a few more students to this score over here, your mode will jump from 15,000 all the way to 40,000. It's just the score that's the most typical. All right, so any questions on that hypothetical analysis? Yep.
So if everyone in the state got 40,000, wouldn't all that data move to the 40,000 mark?
Yes.
Yeah.
Yeah.
Okay.
Yeah. So this is if Elon Musk said everybody in university is getting 40, then we would just have one big huge block all at 40. And if everybody was making the same amount, then the mean, the median, and the mode would all give you the same answer. And we have this, we use this example because it's not symmetrical. Another feature of these is that if your distribution is symmetrical, the mean, the median, and the mode will all give you the same answer. If it's a symmetrical bell curve, right? Because that's what you need for the mode to get in there. So if they all received 40 grand, then everybody would be at this bar right here, and that's where the mean, the median, and the mode would be. In this situation, it's only the high school students that graduate that year and their cohort that are getting 40 grand for the next 4 years. So that's why not everybody is getting it. It's just that one little group. Any other questions? Okay, so this was a hypothetical situation. We're going to end this look at the mean, the median, and the mode by bringing a real life situation into this, and that has to do with the gender pay gap. So you probably heard about the gender pay gap. You probably heard about the situation, the issue where female workers tend to make less money than male workers. And I say tend to make less money because if you delve into the research on the actual gender pay gap. So first off, how many people have heard of the gender pay gap? Okay, good. So this is not news to anybody. All right. So if you delve into the research on the gender pay gap, depending upon how it's defined and depending upon how it's calculated, I have heard estimates of the gender pay gap as high as 50%, so that women are making 50 cents on the dollar. And I have heard estimates of the gender pay gap as low as 1%, so that women are making 99 cents on the dollar for every dollar that males make. So somewhere between 50 and somewhere between 99, those are the numbers that I've heard. The question becomes, why is that gap so huge? Why cannot people agree on what the actual gender pay gap is? Why are we having such disparate numbers? Part of it is the definition that they use for who is employed, who is unemployed. So we're not going to go into that, but part of it is also how they're actually calculating these measures of central tendency. So I'll give you an example. So this is data from 2016. It's the Bureau of Labor Statistics. Okay, so nothing controversial in terms of where this data is coming from. It's not somebody's own little survey. This is, the Bureau of Labor Statistics. This is coming from censuses. This is coming from a large group of data. And they had highlights of women's earnings in 2016. And these are the weekly earnings for women with or without children. So we have women, no children, women with children. And then we got, for comparison, men with no children and men with children down here. And what I want you to focus on is the scores for the women with no children. So women with no children making about $750 a week. Males with no children making about $100 more. So in this case, with these statistics here, there's a gender pay gap, and women are making less than men. Here's another set of data, and this comes from the U.S. Census Bureau Survey of Income and Program Participation. All right, so once again, we're dealing with a wide group of data. We're dealing with a wide collection of data and a reputable source. And once again, we're dealing with, in this case, never married men and women who have never had children. So once again, no children. And they added a few more stipulations: college educated and worked full time, age 40 to 46. And in this case, we find that women's salaries are $47,000, and males in the same category are only making $40,000. So there is a gender pay gap, but it's in favor of women. Women are making more than men are making in the same category. So the question is now, considering what we learned today, and this is from, just so that you know, latest available data as of 2004. So we have data from 2016, women without children making $100 less per week than men with no children. Data from 2004, women with no children making $47,000 a year, men with no children only making $40,000 a year. Why the difference? What is going on here? Why do these numbers not agree? Any suggestions?
One's probably using mean, the other's probably using mode or something.
Exactly. So nobody in this was fudging the data. Nobody in this was doing anything, incorrectly calculating anything. But what it is two different measures of central tendency were used. So if you take a look at this graph over here, you'll notice right down here, it goes, the data is median earnings. median. It did not care about outliers. All it cared about is when it looked to the right, it saw in this, let's say that we had 100,000 men in this survey. If you look to the right, you see 50,000 men. If you look to the left, you see 50,000 men. What score are you at? You're at $40,000 a year. 100,000 women, if you look to the right, 50,000. If you look to the left, 50,000 women. You look above, what's the score? 47,000. This was the median amount of earnings. This was the median measure of central tendency. This one over here, it doesn't mention it. 99 times out of 100, if it doesn't mention it, it's the mean. So this is mean earnings and not median earnings. So that's an important thing to understand, because what that means is that you have to look at the distribution. One of these is appropriate in terms of calculating earnings. The other one is not appropriate in terms of calculating earnings. Without looking at the distribution, I can't tell. I can't tell if they should be using the mean, in which case this story is the true story. This is the representative truth of what's going on. Or should you use the median? In which case, yeah, there is a gender gap, but it's in the opposite direction of what most people believe. So you can see from this example here, it's very important to understand means and medians. It's very important to understand measures of central tendency, because if you use the inappropriate one, then the story can completely change. It's basically the same data, right? I do not think our society has changed from 2004 to 2016. I don't think that males went through some sort of wage earning revolt in the last 12 years, where there was an uprising where they demanded more money, so that they overcorrected this situation and now we're in this situation. That I don't believe happened. But what's going on here is that this is the mean, the other one is the median. Which one is the right one to use? You would need to look at the frequency distribution and see, are there outliers, are there not outliers? If there are outliers, don't use the mean, use the median. If there are outliers, tend to use the median. If there are not outliers, tend to use the mean, because you want to use the most information. But you can see, very important to understand how these are calculated, where these numbers come from, because they can make a massive difference in the story that is being told and how you understand the data. All right, any final questions about or comments about the mean, the median, and the mode? All right, so just a quick reminder, in the MyLab study plan, the Quiz Me option, check the tutorial on the Canvas assignments if you're still having difficulties accessing those mastery points. In the entire book, I believe there's something like 65 or 94, I can't remember the exact number, but there's a bunch of mastery points. Make sure that you're specifically earning the ones for each chapter. So the mastery points for chapter 1 apply to the pretest for chapter 1. The mastery points for chapter 2 apply to the pretest for chapter 2. So make sure that you're focusing your effort in the area that would most benefit you, and take advantage of that to get 100% grades on your pretest. Post-test is coming up. So we got chapter 1 post-test is going to be due by the 27th by midnight, so just have that on your radar. Make sure that you're keeping abreast of your due dates from the syllabus and in MyLab. I'm going to be populating the rest of the assignments in MyLab as soon as possible. But other than that, I have covered what I want to for today. So the rest of the time today will be open to practice time. If you're all staxed out, if it's been a hard week, feel free to head on out. Take it a little easy and a little early today. But if you want to stick around, I'm going to be here until a quarter after. Try the Excel sheets. Get started on, take a look at some of your homework. We're not quite ready to tackle the first chapter 2 homework yet, because we still need to do a little bit of the variance, but you can definitely take a look at it. Excel sheets, anything like that. If you have any questions about anything, let me know. Call me over. But other than that, I'm done covering what I wanted to cover for today.